Welcome all to Newton's laws of motion class 2, in which we'll discuss about Newton's second law. So this Newton's second law states that the net external force acting on an object is directly proportional to the rate of change of its momentum. So let's see first what do you mean by this term momentum over here. The term momentum in general, it is represented by p vector, is a product of mass of object and its velocity. So if an object of mass m which is moving with the velocity v, so its momentum is the product of mass into velocity, and as it is a vector quantity, the direction of momentum is along the direction of velocity, and the unit of this momentum is, we can say that the unit of mass is kilogram and unit of velocity is meter per second. So kilogram meter per second is the unit of momentum. So remember these points about momentum. Momentum is a product of mass and velocity. Momentum is a vector quantity and the direction of momentum is along the direction of velocity. Now we'll come back to Newton's second law. So it states that the external force or the net external force acting on an object is directly proportional to its rate of change of momentum. So let's see what do you mean by rate of change of momentum. So we can represent it something like this. Net external force is directly proportional to rate of change of momentum, means nothing but the change in momentum divided by time. So we can write the value of net external force is directly proportional to rate of change of momentum, that is change in momentum by time. Change in momentum is final momentum minus initial momentum divided by time. So we can write the value of net external force is directly proportional to, you know that the final momentum is the product of mass into final velocity. So we can take it as m into v. Over here we are just considering that the mass of object is a constant. We'll discuss the situation if mass is not a constant. And the initial momentum we can take it as mass into initial velocity divided by time. So you can write the value of net external force is directly proportional to, if we are taking this mass as a common, so it is v minus u divided by t. So you know that v minus u by t is nothing but representing the value of acceleration. So you can write the value of net external force is directly proportional to mass into acceleration. So we can write the value of net external force is equal to a constant into mass into acceleration. Over here the unit of force is taken as nothing but 1 Newton, and the value of 1 Newton is nothing but 1 kilogram meter second raised to minus 2, and so that we are keeping the value of this constant as nothing but 1. So we will write the value of net force is equal to, we are taking this constant as 1, so it becomes product of mass into acceleration. So the general equation that we are using for force according to Newton's second law is net force is equal to mass into acceleration, and it is a vector quantity, so we can write the direction of net force should be along the direction of its acceleration. So if a force, constant force is acting, so we can write if the net external force is equal to a constant and the value of mass of object is equal to a constant. In this situation we can use that equation, force is equal to mass into acceleration. Now if we are considering a situation in which the value of force is not a constant, is forces keep on varying, then we'll find out what about the value of instantaneous acceleration, or you can write the force in terms of instantaneous acceleration. So take it as this force is not equal to a constant and the value of mass is equal to a constant. So you can write the same equation by using that differential form, that is f is directly proportional to rate of change of momentum. So we'll go for the instantaneous change in momentum. Let's say that is represented by dp divided by dt, or differentiation of momentum with respect to time. So we can write f is directly proportional to, if mass is a constant, this momentum is nothing but the product of mass into velocity. So we can write it is d by dt, or differentiation of m into v. Over here, if mass is a constant, we can write it as m into dv divided by dt. In kinematics, we already discussed that this dv by dt represents the instantaneous acceleration. So we can write this force is directly proportional to mass into instantaneous acceleration. So we'll write the equation as force is equal to mass into acceleration. So the difference between the previous equation, that is F is equal to m into, and this equation is, over there the force is constant and acceleration is constant. Over here the force is instantaneous, so the acceleration is also instantaneous. Now if you are considering a situation in which if the value of mass is not a constant, if this mass is not equal to a constant, then how we'll write the equation for force? So you can write force is equal to, again, or directly proportional to rate of change of momentum. So you can write this as dp divided by dt, and we discussed that this momentum is nothing but the product of mass into velocity. If the mass of object may be changing, and that means like in case of rocket propulsion or any other situation, the mass of that object is changing, then we need to differentiate both the term. Means we can write f is equal to differentiation of m into v as a function of time. So if there are two variables, then definitely we should go for product rule. So we'll write first function into differentiation of second function plus second function into differentiation of first function. So this is going to give the value of net force acting on the object. Or you can write this dv by dt represents a value of acceleration. So you can write this as m into a plus v into dm divided by dt will be the value of net external force acting on the system. Hope so that you understood what are the things we discussed in this class. If you are having any doubt, please contact. Thank you.